Hi, I'm Polina Guhryeva. I'm an assistant professor of biomedical informatics at the University of Utah. I recorded this short video to explain what my lab works on, how we think about research, and what it is like to work with me as a PhD student. If you're interested in AI for healthcare, real-world data, or using machine learning to make clinical decision-making more equitable, this video should give you a good sense of whether my lab is a good fit for you. So I'll briefly talk about motivation for my research, vision, and values of the lab, our current aims, and next step and requirements for prospective PhD students. Okay, so the core problem my lab works on is diabetes pharmacotherapy. We have many effective medications for type 2 diabetes, but in practice, treatment decisions are still largely heuristic. Patients with similar diagnosis receive very different therapies, and outcomes vary substantially across populations. Only about 1 in 5 adults with type 2 diabetes have HbA1c, blood pressure, and lipids uh, all at the goal level. And the intensification of treatment is often slow for patients with HbA1c above 8. At the same time, we now have access to massive electronic health record datasets, including national EHR networks such as Epic Cosmos and Genetics. These datasets contain longitudinal medical histories, lab values, outcomes, and clinical context for millions of patients, pretty much all patients in the United States. Uh, Another enabler to solve diabetes pharmacotherapy problems is acceleration of AI, artificial intelligence. Um, so GPUs and hardware in general became much better. In the last 10 years, there were breakthrough in AI architecture, such as transformers, and massive digital datasets, such as electronic health records, became available, as well as cloud scalable compute, as well as specific algorithm advances such as ADAM optimizer and patch normalization techniques. And AI now is open source ecosystem. Um, Also, foundational models are now available for medical data, and transfer learning could be used to apply these foundational models to smaller data sets and adapt them. So this is a huge industry and there is a huge government investment. So we want to use AI to improve diabetes pharmacotherapy for patients in the United States. So the challenge is that while this data is abundant, it is very hard to translate it into actionable, personalized, and fair decision support because these data are often missing, inaccurate, sparse, and biased. So just recently there was this preprint from Epic Cosmos group, and you could see on this slide that they tokenized patient data and they use it to predict potential futures for patients. For example, they could run 100 simulations, and if you have a heart attack in the next 5 years in half of these simulations, they believe that it is actually likely to happen in real life as well. So my lab sits on the intersection of these 5 academic and clinical areas: biomedical informatics, with using electronic health record data and developing clinical decision support interventions, as well as computer science with AI, deep learning, and big data, medicine for chronic disease management, because type 2 diabetes is a chronic disease, and then pharmacology. We focus on post-market surveillance and pharmacoepidemiology, and biostatistics, where we focus on causal inference and emulated clinical trials. Okay, so my lab vision is to develop data-driven solutions that transform healthcare for patients, clinicians, and communities by turning real-world data into meaningful, life-improving action. And if you're interested in this lab vision, you should absolutely apply to our PhD program. I want to say a bit about lab culture because that matters as much as the technical work. We prioritize three values. First, honesty, which is clear communication, intellectual integrity, and psychological safety. Second, growth, continuous learning, and intellectual curiosity. And finally, stewardship, managing time and energy in a way that supports both strong science and well-being. Aim to give direct, constructive feedback and to be transparent about my expectations. My goal is to help students build a research portfolio they are proud of and that positions them well for academia and industry. For the next couple of years, my lab will focus on developing predictive AI models for diabetes pharmacotherapy and developing a clinical decision support tool based on these predictive models. On this slide, you could see a prototype of a clinical decision support tool which we aim to develop. Although the American Diabetes Association ADA guidelines support diabetes medication selection based on major comorbidities, they primarily provide broad medication class level recommendations. In practice, clinicians must make more granular decisions within drug classes, considering differences in HbA1c reduction, weight effect, hypoglycemia risk, side effects, and cost for each patient. For example, patients with ASCVD may be eligible for several GLP-1 receptor agonist treatments with similar cardiovascular benefits, but differing effects on glycemic control and weight. This gap creates an opportunity for clinical decision support that leverages real-world data to provide personalized drug-level comparisons, complementing existing ADA guidelines and supporting more precise treatment decisions for each patient. In AIM1, we are building what we call Dream 1.0, a set of predictive models for diabetes pharmacotherapy using large-scale real-world data. The goal is to predict how different treatment choices affect outcomes that really matter to patients, specifically HbA1c, weight change, and the risk of severe hypoglycemia in people with type 2 diabetes. DREAM 1.0 uses deep learning models to estimate individualized outcomes for different guideline-compliant medications, such as semaglutide, and tirzepatide, based on patient clinical profile and comorbidities. So rather than giving one-size-fits-all recommendation, the model generates personalized ranking of treatment options, showing which medications are most likely to lead to better glycemic control, weight outcomes, and lower hypoglycemia risk in a specific patient. Our hypothesis is that when clinicians use these personalized predictions, they can make better treatment decisions than by following guidelines alone, leading to improve outcomes over about 6 months. To build these models, we train them on electronic health record data from three large sources: Epic, Cosmos, Genetics, and a dataset from Northwestern University in Chicago called AHEAD. Okay, so aim 2 is to quantify disparities in diabetes pharmacotherapy using descriptive AI methods, such as clustering. We hypothesize that cross-institutional HR data repositories and clustering methods could be used to quantify disparities in diabetes pharmacotherapy prescription patterns in three vulnerable populations: people identifying as racial and ethnic minorities, people with low socioeconomic status, and people living in rural areas. So to quantify pharmacotherapy prescription disparities, we will analyze millions of raw medication sequences and transform them into distinct medication trajectories. These trajectories will be further grouped into a manageable number of medication trajectory clusters, allowing us to identify patterns in pharmacotherapy in different populations. By analyzing these clusters, we will be able to determine whether specific medication regimens are predominantly associated with vulnerable populations. Finally, aim 3 is to enhance our dream models for use in vulnerable populations. We hypothesize that biases in HR data will lead to lower predictive model performance in vulnerable populations due to lower relative representativity in the dataset and discriminatory patterns present in the data that are learned by predictive models. We also hypothesize that targeted data augmentation coupled with utilization of responsible AI method for algorithmic adjustments will improve model performance vulnerable populations. Okay, so that's aim 3. So what I'm looking for in the PhD student. So I'm looking for someone with MS in computer science, data science, or related field, preferably from United States to simplify visa application process, proficiency in Python and experience with machine learning frameworks such as PyTorch and TensorFlow, experience with LSTMs, GRUs, and transformers, and interest in applying AI to healthcare. Commitment to honesty, growth, and stewardship, exposure to large real-world data sets such as electronic health records or claims data, and strong communication skills. So the lab currently is funded with NIH funding, my KO1, University of Utah Delphi seed grant, aim ahead fellowship, and University of Utah Responsible AI fellowship. And in the future, I hope to also receive faculty startup funding from the University of Utah. So thank you so much for taking time to watch this. I hope it gives you a clear sense of what we do and how we work. I look forward to connecting with you. If this resonates with you, I encourage you to apply through the University of Utah DBMI PhD program. Due to the volume of applications, I am unfortunately not able to review application materials or respond to individual inquiries prior to submission. But we look forward to your applications. Thank you.